All right, let's get started. Hello, everyone. I hope you're having an awesome Dev Summit so far. My name is Flora Vale. I am a product engineer on the analysis and geoprocessing development team in Redlands, and this is my colleague, Tom Wason. He is a front-end developer on the ArcGIS Hub team. And this morning, we'll be talking about charts and custom visualizations beyond the map. I'll start by discussing the importance of data visualization, a little data viz theory, some do's and don'ts, and how this all applies to spatial analysis, and how we've begun to implement this in ArcGIS Pro. And then I'll hand it over to Tom, and he'll tell you about the charting development that's taking place in the hub and how you can leverage this to create your own custom visualizations, since this is the Developers Summit and all. Okay, so what is data visualization? Well, simply put, data visualization is a graphical representation of data. It's the use of symbols as metaphors to represent quantities and categories in context, allowing you to make comparisons and intuit proportions, patterns, relationships, and trends. Here are some examples of the classics. You didn't think that you were going to get through a data visualization talk at a mapping conference without seeing a Jon Snow cholera map, did you? Don't worry, I won't spend too long here, but the reason that you see a Jon Snow cholera map at every talk is because it was really, truly transformative. Each of these examples, visualizing the data not only made it easier to process, but it also uncovered insights that would have been virtually impossible to find without the actual visual representations. Jon Snow was able to pinpoint the contaminated water tap by identifying a spatial cluster of cholera cases. Florence Nightingale was able to show that epidemic disease was causing more British deaths than battle wounds during the Crimean War. Charles Minard elegantly incorporated several dimensions, including time, location, number of deaths, and temperature, all in one visualization, telling the story of Napoleon's march. And though not as historic, but nearly as iconic, Hans Rosling wowed the world with his animated visualizations of global health and life expectancy changes over the years with his 2006 TED Talk. In summary, we visualize data to convert slow reasoning tasks into fast perception tasks so that we can intuitively perceive relative differences instead of having to hold information in memory and make mental calculations. This process of visual perception is pre-attentive, meaning that it happens automatically with virtually no effort, in contrast to attentive processing, which requires conscious effort and calculation. So for example, if I were to ask you to identify the largest value on this slide, it would be a pretty tedious task. And it would require a lot of conscious sorting and searching and a lot of memory and effort. But if I were to show you this slide and ask you to identify the largest value here, you'd be able to find it instantly. No processing required. That's because these values are now represented as visual variables. In 1967, a French cartographer named Jacques Bertin published what has now become a fundamental reference in data visualization theory, titled Semiology of Graphics. In this book, he describes visual variables and how they can be used to communicate data visually. More work has been done on this since, but these original visual variables are still the foundation of most data visualizations. So we're looking at the position, size, shape, value, hue, orientation, and texture of visual elements. So in this visualization that we looked at before, we're perceiving the relative length of the bars by comparing the position of their endpoint. And many researchers agree that position is the visual variable that humans are best at perceiving, which is why bar charts are so useful and ubiquitous. Of course, we could also use size, hue, orientation, or any of the other visual variables to make that text stand out. Not all visual variables are appropriate for every data type, though. Noah Alinsky, who is a thought leader in the data visualization space, put together this great table detailing the best practices for visual encodings. So for example, size is a good way to represent quantitative and even ordinal data, but not appropriate for categorical data. Color can be a good way to represent categorical data, but only when there are few categories. So there's a lot to consider when deciding how to encode your data visualization with visual variables. All of this is important to keep in mind because not all charts are created equally. Understanding how our eyes and brains perceive visual variables is key for effectively communicating through data visualizations. So let's go ahead and get this one out of the way. Pie charts, though beloved by many, are not the most effective way to represent proportions. Understanding a pie chart requires us to visually compare angles. And that can be difficult to do, especially when there are many present. Looking at these three charts, it's not immediately apparent which slices are bigger and which pies. Of course, we could figure it out if we took some time and did some measurements, but why take the time when we could just represent this as bars instead? Now we don't need any attentive processing. As I mentioned earlier, we're really good at perceiving length, and when I show you the bar charts, the amounts are immediately obvious and distinguishable. So what's worse than a pie chart? A 3D pie chart. There are whole corners of the internet dedicated to criticizing the misleading visualizations used in Apple keynotes. Notice how the pie is tilted just right so that the 19.5% Apple market share slice appears bigger than that 21.2% slice in the top corner. And the donut chart. The donut chart may be a prettier version or a cooler version of the pie chart, but actually it's even harder to decipher because the angles that we're using to understand the quantities have been removed. So now instead of visually comparing angles, we're left to compare arc lengths that don't have the same origin point. So it's really hard to tell what's going on here. And then of course a 3D donut chart, just please, I beg you, don't do this. Most of these rules have exceptions. I'm not saying it's never correct to make a pie chart, but I'm gonna go ahead and say that 99.999% of the time, it's not okay to make a 3D donut chart, so please. With very few exceptions, 3D charts are highly discouraged. While bar charts are often the most dependable and easy to read of the visualizations, when drawn in 3D, they become harder to decipher. So up in this corner here, which edge am I comparing to the axis? Where does it start at the bottom? I'm not really sure if I'm supposed to look at the top or the bottom. And over here, what's hiding behind this bar? There's no way of telling. And these charts could have been represented with a lot less chart junk, as Tufte calls it, by just putting them in 2D. The 3D added absolutely no value and in fact just obstructed our ability to clearly see the data. Another way to obscure the trusty bar chart is to remove its origin. So bar charts must always include 0. This is very important because when we're looking at bar charts, we're perceiving relative length. So in the example on the left, the preoperative value appears to be less than half of the postoperative value, when in fact, the difference is much less severe when we look at the chart on the right. So including that 0 origin is a must. The next chart faux pas is using lines to connect arbitrary categories. So again, with few exceptions, lines should only be used to visualize change over a continuous variable, like time or distance. Using lines to connect discrete categories, like states in this case, just doesn't make sense. So again, a bar chart would have been a lot more appropriate way to show state values. And here is our last chart crime of the day. There is this great website called WTF Viz, and people submit misleading, incorrect, or otherwise terrible visualizations. I find it to be a lot of fun, but maybe that's just me. This one is one of my favorite examples. So we're looking at the number of murder and homicide cases reported. And at first glance, it looks like murder and homicide is decreasing significantly. But then if you take a closer look, each data point represents the count of crimes recorded for one full year, except for the last 2 data points. The second to last point counts only crimes from January to June, so just 6 months of data. And the last data point counts only from July 1st to August 3rd, so just 1 month of data. So comparing all the crimes that happen in 1 month to all the crimes that happen in 1 year, of course that's going to be a smaller number. I mean, it's hard to believe that this visualization mistake was made unintentionally. So limiting misleading or inappropriate visualizations while trying to create useful ones is a delicate balance. In designing the charting UI and UX for ArcGIS Pro, I have to think a lot about, giving users enough freedom to create the visualizations they need without allowing them to do things like bin time charts with different size bins, or create a bar chart that doesn't have a zero origin, or connect categorical data by lines. So I had to make the choice to not allow for those parameters to try to guide our users toward making useful and accurate visualizations. But I also don't want to limit people that have a very specific or kind of niche use case for a visualization that wouldn't commonly be recommended. So in designing the UI and UX for Pro, we tried to incorporate data visualization theory into the parameter options and provide smart defaults to help guide our users to effectively visualize their data. So we've made it as difficult as possible to create bad charts while making it as easy as possible to create good ones. And in deciding what chart types to include in Pro, we really focused on supporting our users in their spatial analysis workflows. So in a spatial analysis workflow, the important steps requiring data visualization are exploring your data, interpreting analysis results, and communicating findings. So exploring your data involves looking at the distribution of your data. Is it normally distributed? Are there outliers? Is your data healthy? Are there different relationships that require further examination? Interpreting analysis results involves now, with many tools in ArcGIS Pro, we actually output a chart with your output layer. So you run a geoprocessing tool and you get a layer and also a chart that helps you interpret the output. And then communicating findings. Charts are visual communication tools. So we want you to be able to explain your analyses through visualizations, not just maps anymore, but also charts. And the different functions that we needed to support were visualizing distributions and frequency, visualizing category comparisons, relationships and correlations, and change over time or distance. So with distributions, we're understanding the shape of numeric data. So we can create a histogram, we can create box plots. We've also included QQ plots recently, which are used to compare 2 distributions to each other. The box plots are great because you are comparing multiple distributions across categories. And the histogram, of course, is just one of the most classic ways of examining your data. For looking at categories, we have the trusty bar chart. And we've included different ways that you can visualize bar charts. So you can summarize and aggregate data without having to create a new table in the bar chart UI. So let's say I have a table of counties and I have a field for the state name. I could make a bar chart by state, and it would summarize in each bar whatever aggregation method I chose, whether it be a sum, a mean, a median, or a count. and relationships. So we have included scatter plots as a way of looking at relationships. Right now, we will return to you a linear trend with an R². We are looking to add different trend types in future releases so that you can look at not just linear relationships, but other ones as well, maybe polynomial or exponential. And one really cool thing about many of these charts, especially the scatter plot, is that the points in the chart will keep the color, the symbology of your map layer. So in effect, we're adding a third variable to the scatter plot by including a third numeric variable as the renderer. And the last category is change. So visualizing change or cycles over time or distance. And this one, usually we just think about change over time, but since we are geographers, we also occasionally look at change over distance. So we have a line chart that has time aggregating options built into it to help bin your temporal data or your incident data. And we also have a profile graph that you can input a 3D line feature and see what the kind of profile slice would look like. So basically, what I've been trying to say this whole time is that a map alone is not always the best option. I think it's safe to say, based on where we are, that most of us understand the value and importance of putting our data on a map. And I am never going to tell you not to map your data. I love maps. I am a geographer first and foremost. But there are some instances where a map could really benefit from a companion visualization. So state maps are a great example of that. We see state maps all the time in the news and in different publications. And I'm never going to tell you not to make a state map. But they can be a little bit frustrating to me. Because usually in the case of state data, the location is not the most meaningful attribute. We're not looking at this map to figure out where California is. We want to know what the different relative differences are in values associated to these states. So usually when we map things, we're doing it because we want to show spatial relationships. The first law of geography being that things that are closer together are more related than things that are farther apart. But that's not really the case for states. They are so large and political that states being near each other does not necessarily mean that they have any sort of relationship in space. If we were looking at a county layer or a census tract layer, then the spatial patterns become very apparent. But looking at whole states, it's not the most efficient way to compare these. And also, some states are so tiny that we can't even see them on the map, and so they kind of get lost. And here we can see clearly the states that have the darkest values, right? But of those states with the darkest values, which one has the highest value? It's impossible to tell by just looking at this map. So in addition to your map, why not create a bar chart? Now we can immediately tell which state has the highest value. And I believe that it is, in this case, Nevada. So even looking at this unsorted bar chart, it's sorted alphabetically. We can quickly see the tallest bar. And if we really wanted a better look at the relative differences, we could sort these in descending order and get an idea of that shape. So again, I'm not trying to replace the map, but I am trying to enhance it with other visualization tools. And if you make these charts and maps in Pro, they're interactive, which is a big part of the exploration process. So if I were to click one of these state bars, that state would select on the map. And you would have that interactivity between the map and the chart and also the table. Another example when a map alone isn't the only or best option is when looking at temporal data. There are many tricks to looking at temporal data in maps. Sometimes we look at things animated over time, which can be interesting, but that does require some memory. You have to kind of keep in memory the things that you've seen previously. You can use small multiples, so many maps. That's a great way of doing it. You could also do some sort of summary, so map change over time with a choropleth, like rate of change or something like that. Or looking at them in 3D. We also do that with a lot of the space-time cube tools. But looking at a line chart is also a really great way of exploring time. And when we think of time, we often just think about linear, days or years or months. And I showed that chart earlier that had that kind of cyclical pattern that we see in a lot of this data. But another interesting way to look at it is to kind of split it up by hour of day and day of week. So this is car accident data that I pulled. And I put along the x-axis hour of day, and I split this into 7 categories by day of week. And then I color-coded it so that Monday through Friday are kind of in these blue tones, and then Saturday and Sunday are in the pink tones. And you can see that the weekend has a very different car accident pattern than the weekdays. And that's not surprising, but it's cool to see it. This is not something that would be able to capture easily with just a map. So 2 a.m., definitely the most dangerous time to be traveling on a weekend, and kind of those rush hour humps are the most accident-prone times throughout the week. Another example, this is another classic, this is Anscombe's quartet. So these 4 data sets have the exact same mean, the exact same median, the exact same standard deviation, and the exact same R-squared. So we might think that they're all very comparable, when in fact, if we were to plot these using scatter plots, we can see that these are actually all very different shapes. An outlier here or there is pulling those summary variables and allowing the summarizations to be the same when we are kind of missing the picture by just looking at the summary. Understanding things like a mean or a median or a standard deviation are very useful. We use those to summarize large quantities of data and kind of boil down and get a sense of things. But oftentimes, it's dangerous to just look at a mean value, for example. If your data is not normally distributed, so that kind of bell curve shape, the mean is not actually indicative of the most. It's not a normal value. So let's say that we were looking at, I don't know, maybe Esri employee annual salaries. And most of us are over here, and then maybe top of the food chain, there's one really high salary over here. The mean is going to be in the middle where actually not very many people are. So, and you could say, the average employee makes X amount of money, when in fact nobody makes that amount of money. So if I looked at that on a histogram, it would be clear that that mean was not indicative of the whole. Another kind of funny way of thinking about this is the average person has one fallopian tube. So I'm sure there are many people that have one, but most people either have 2 or 0. But if we were to take that average, the average person has one, when in fact most people do not have one. So it's important to realize that these summaries are not by themselves the whole picture, and that visualizing that data, you would see a bimodal thing, that we'd have a mode for 0 and we would have a mode for 2, and 1 would kind of be empty even though it lands on the mean. So I have some demos, but full disclosure, we were having a little bit of trouble earlier because I was brave and went on a daily build to try to show you some of the new things that we have going on. So, and I went over a little bit, so I'm going to just take a couple of minutes to show you some of these charts in Pro. So I have this data set of Medicare beneficiaries and the health of the population. So how much we're spending per beneficiary in each county, and the prevalence of different chronic conditions. And of course, the first thing I do with a table like this is I put it on a map. And like I said before, a county map is actually very useful to look at these trends spatially. We see always with the health maps that kind of that southeast pattern of less healthy. So here we're looking at the health of the population, and the kind of northwest tends to be healthier. And now that we have these charting capabilities in here, we can explore these variables. So the average HCC score is that health index. I can now right-click and look at the stats and create a histogram. I can add overlays of the normal distribution, mean, median, standard deviation, and I get all of these other important variables associated. If I were to look at a different variable here, like the number of beneficiaries, we see that skewed distribution I was talking about earlier that is not representative. And oftentimes we need our data to be normally distributed, and we can try different transformations. So now we've applied that as well. So as you explore your data, you can maybe apply a logarithmic transformation and see if that normalizes your data. So different ways of exploring your data on the fly. And I want to jump over here to this data set here. So we're looking at temperature measurements in the ocean. And we can create these charts manually, but since this is the developers conference, I would like to show you that you can also do these programmatically through ArcPy. So let me point here to my PYT. And so a colleague of mine built this tool for me, and I'm gonna just open it here really quickly and take a look. So what we're gonna do is we're going to take an input, which will be temperature. We're going to create a histogram, a scatter plot, and a line chart. And I'll point to my data here, point to my analysis fields, and run that tool. So now through ArcPy, the new chart class, we can create these programmatically, and they have been added here to my layer. So I can open these up and take a look at the different values that are associated with these temperature measurements. And the very last thing I want to mention, since I have 2 minutes left, is the analysis results. So many of the spatial statistics tools have begun to include charts as part of their default outputs. If I look at the multivariate clustering tool, which is a k-means plus algorithm, this is a type of analysis where you absolutely need a chart to interpret the results. So I'm going to run this really quickly and I'll show you what I mean. Oops, what are we doing here? What's missing? That's not what I want. Okay. So this tool is basically looking at these features and splitting them by value. We're looking at vulnerability in Africa over different types, so based on population governance, climate change, and household resiliency. And I asked it to split this into 4 different groups for me. So just looking at this map, we can't tell what the 4 different groups mean. So now, if you look over at the list by charts layer, you can see that these analysis tools are now outputting charts programmatically through ArcPy. So I can open these box plots and understand what this map means. So the yellow areas are high in vulnerability and governance and household resiliency, while the blue areas are high in vulnerability due to climate change, which kind of makes sense, being that they are on the edges. So I talked about exploring your data, analyzing and interpreting your analysis results, and the final frontier is communication. So what we're really working on now is the ability to get these charts that are created into Pro into our web applications. So we've begun working on a shared web map spec, and that is in the works. And I will now hand it over to Tom to tell you about Cedar and all of the other cool web stuff we have going on.
Thanks, Flora.
Thanks, guys.
Yeah, like hard act to follow, you know? I'm used to being the first person talking, so.
I'm going to flip to 3.
Oh, yep. So yeah, if you're like me, they've been doing great work over in Pro and Python, and if you're a web developer like me, there's not a whole lot of way for you to benefit from that yet, and that's what we're working on. So we've in the DC R&D Center, we've been working on a library called Cedar that you may have heard of before, and the goal of Cedar is to be a JavaScript library for charts for ArcGIS. And I'll tell you about a couple of Cedar's core philosophies. Obviously, we want to be deeply integrated with ArcGIS. Now, you're already using data that's coming from feature services or a map. You've got features. Cedar needs to handle that. But also now, more and more these days, integrated with ArcGIS means working with the kind of charts that other parts of the platform are building. Cedar also wants to have smart defaults, wants to provide you with smart defaults. They're not as smart as Flora's defaults, But we're getting there. And a lot of what that means today is that we're working with Pro to understand what the work that they've already done and how we can bring that into Cedar. If the smart defaults don't work for you, we also provide an escape hatch. So we will let you make a 3D donut chart if you want. We at Cedar empathize with you, the developer, because you have clients. And clients sometimes like donuts and pie. I like donuts. I also like pie. So, and finally, the last sort of tenet of Cedar is that we want you to be able to extend, it comes with these built-in chart types that have smart defaults. We want you to be able to extend it with your own, maybe something that works for your industry, and then share that with others. So the process of working with Cedar, it usually starts with a developer that has some idea or requirement of a chart that they want to build. They have data that's coming either from the cloud or from a map that they've got there in the browser. And this is where Cedar comes in. We have you create a definition. And we'll talk about what a definition is. We pass that definition to Cedar, and out comes a super cool chart. So let's build this chart together. First thing with Cedar, you got to have it installed. You can install it with a package manager of your choice, npm, yarn, and you can also bring it in from CDN with script tags in your browser. At this point, it's probably worth talking about why there are so many script tags. Cedar has a dependency of an underlying charting library. At this point in time, that library is amCharts. If you've been doing any JavaScript development, you know there are more JavaScript charting libraries than there are JavaScript frameworks, more JavaScript charting libraries than there are JavaScript developers almost, it seems sometimes. And each has their own strengths and weaknesses. So Cedar does not intend to compete with those. Instead, we try to be the bridge between the ArcGIS platform that you're already working with and another library. Previously, Cedar had been implemented on top of D3 and Vega. Currently, it's amCharts. We hope to, in the future, we're working on an engine model where you can have plugins for individual, people can author their own plugins for underlying libraries. That's in the distant future. So let's go back to that definition. It's just a POJO, a plain old JavaScript object. It has to have three things at a minimum: type, data sets, and series. Type is, we have, like I said, these built-in predefined types such as bar and some others that you might be familiar with. You can also, like I said, provide your own specification, which would be a JSON definition specification. We'll talk about that later. Now we need data, and oftentimes when you're working with Cedar, the data is going to come from a service, a feature service, so you supply a URL. And optionally, you can also supply query parameters. And then finally, series is what takes these two things and brings them together. It says, okay, given the data that we got back, take this field and plot it this way on the chart. So once you've created your definition, you're going to create a new chart instance by passing an element ID, some div, some DOM element in the document, and pass in the definition. And that here I'm showing if you're using ES6 or ES6 2015 TypeScript, sort of more modern JavaScript, you would import chart from Cedar. Cedar is also distributed, as I showed, as a UMD module, so there's a global Cedar that you can create a new chart from. And finally, click Show, and that will show the chart on the screen. Before I start talking about the different types of charts, I want to talk about different ways to get data in. I showed you how to pull data from a URL with a query. We can also, oftentimes you have a map there on the screen and you may not need to go requery the data. And we'll talk about the times when you would and would not want to do that. The state map is a good example. So this would be one of those times when the features on the map actually correspond one-to-one with the plots that you want to show in the chart. So making this chart, instead of passing a URL, we're going to pass a property called data to that data set. And the graphics here, the data expects a feature set. If you're familiar with this, it's pretty much an object that has an array of features, as well as some other things. But the only thing Cedar that we use is the array of features. When you're working this way, you are going to be responsible for handling the sorting, filtering, and those sort of operations on the client there yourself. Fortunately, though, this is not difficult to do in JavaScript. You have an array of objects, so you can, arrays have a filter method, they have sort methods. So when you're working like this, you're probably, you're not passing, you don't have the query, the power of the query definition, but you're able to manipulate the array right there yourself. Pretty often, though, what you'll find is that you'll want to be working with aggregate data. So if you have points, for example, all the points on the map, you may not want to show a bar for each one of them. You may want to aggregate them, in this case, by state. So building this chart would look something like this. Instead of passing the feature set as a data property, we're going to pass the URL. And in this case, we're going to provide summary statistics for the query. And it may seem, you may be thinking, geez, I already have the points here in the browser. Why do I have to go make a subsequent request? These summary statistics, they're low bandwidth requests, right? They're only coming back with a few points of data. And it's a balance. Otherwise you would have to write the summary code inside of the browser there yourself, execute it in the browser. So depending on, there's no hard and set rule about which you would use. It kind of depends on the power of the service on the back end, how many features you have to work with and manipulate in the browser, and how easy it is to write that query versus manipulate the array there yourself. But Cedar allows you to do either one. You have either option. In addition to summary statistics, you can pass any query parameters. So, where clauses, order by, any of the valid query parameters that you're familiar with when working with a feature service. So, you probably don't want to make bar charts all day. So let's take a look at some of the different types of charts you can make. And so this page, and I'll see if I can bump it up here. Is that kind of halfway decent? This is what serves as Cedar's documentation these days, is this page here. And we're already familiar with the bar chart. This is one of those bar charts that is doing an aggregate query. And what's cool about this page is that you can go in here and edit the JSON config and play with it and make your own charts. Oftentimes, changing chart types is as simple as changing the type from bar to line, and now you have a different chart. We show over here on these other, but that might not be the best example of what a line chart is. Flora probably looked at that and was cringing, like, no, don't take those aggregate points. You should be showing time data. Okay, so here's time data. So we have all these examples here, and I'm not going to go into the specifics of the code of each one of them. Like I said, it's usually just a matter of changing that type field and providing it with the appropriate type of data that Flora would approve of. So, but just to kind of demonstrate what the different charts look like, we have bar, area, we have scatter plots. We can also make a bubble plot with just sort of changing the size of the scattered. And also we can do grouping for different charts, for bar charts. We can stack them, and we can rotate bar charts to be horizontal. So a lot of these are our built-in types, and if some of the built-ins are not working for you, and I should mention, we do have a type called pi, and it is a donut. So do with that what you will.
Which is nothing.
which should be nothing. Yes. Yes. So again, if the decisions that we've made for you aren't really working for you, then we have also the definition. You can provide something called an overrides. parameter, and that will allow you to go and pass in these parameters that change things like the axis labels, the category rotation, the label rotation, whether or not the legend shows. And all of these parameters, you may be wondering, where do I find out what those mean? Every time you work with overrides, you are talking directly to the underlying chart library. So if you go to the amCharts documentation, any parameter you can pass into amCharts, you can put into overrides and it will be applied to the Cedar chart. So that's good news and bad news. It means that we can provide something very simple that is, we can maintain, works for our purposes, you guys can use it as well, and then you can extend it. And the possibilities with amCharts are pretty much limitless. They allow you to make a lot of bad charts. But it would be better if Cedar had a higher level API that helped abstract you from this. And this is something that we're working on now. So in the case of, in this example here, we said, legend enabled true is something that we wanted to have happen on this chart. A better way is to use Cedar's own legend property to specify that. So we are expanding the footprint of Cedar's own definition to include things beyond just type data sets and series. And we're also doing that in concert with Flora and other teams at Esri to make sure that the definition that we come up with is something that can kind of jive with other teams, at least be able to import the types that are generated from Pro, let's say. So everything I've been showing you is Cedar v1. And compared to v0, one of the big things that we have been working on was vastly improving the experience for multi-series charting. We're all in the process of that. We also, if you've worked with feature services and querying, they're really powerful. There's some really great query capabilities, but you do bump up against limits. It's not like you can just, you're not really typing full SQL expressions into a URL and getting back, these case wins and grouping and having and all that. There are limits to what you can do. So, and we've bumped up to some of those limits ourselves inside a hub. And the way that one of the ways that we've been working around that is by allowing you to make multiple queries and join the data on the client side. So Cedar's data sets used to be data set. Now it is data sets, and you can join static data that you have in the browser there that you may have pulled from a feature layer with some other layer from other data that you get from a query. Because we've moved to a promise-based API, you have more control over the timing of how, you have better control of the data flow. We used to have to expose a lot of events, better control of error handling. When you call show, it returns a promise, and you can manipulate the data before it gets shown on the screen. Oops. And like I mentioned, underneath the hood, it's now amCharts instead of Vega and D3. I don't know if that's an improvement, or I would say it's probably just a wash, neutral. They both have their own strengths and weaknesses. So a confession, though, is that V1's still in beta. And you're probably thinking, well, why am I here? Look at this guy's leaving now. You had me until beta. And the reason that I'm going to keep calling it beta is because there are gaps from V0. So V0 had documentation, which was nice. People like that. You were able to configure the tooltips in V1. You can basically just turn them on or off. You don't have like a full templating capability with the tooltips. We had chart events like clicking and mouse over. We don't have those yet in V1. And the selection that Flora mentioned, that interactivity between, say, a map and selecting the chart. And the reason that I want to be full disclosure about that is we are using Cedar v1 beta in production in the hub and have been for a while now. So in terms of its core capabilities, they're solid. You can use them. We use them in production every day. To give you an example, this may be sort of what you're at all familiar with in the open data capability. If you're looking at open data set, you have these it shows all the fields, and this is that data exploration step that Flora talked about. So if you go and look at one of these, you'll click on one of these, it has the chart indicator, you're able to see the chart there. And we do some different things there in terms of whether it's a text field or a date field, in terms of whether we're going to show you a bar chart, categorical bar chart, or a distribution with a histogram. But really, what is happening right now with Cedar in the hub is our hub users are driving the requirements. So our hub users are building pages to support their initiatives, and they need to be able to show really nice looking charts. They need to be able to track indicators and performance on these initiatives. And so, you know, this is an example of LA GeoHub. This is a chart that they came to us a while back and said, we need to be able to make this. We can't do it right now in Cedar. So these are the kind of things where this is what's driving us to try and be able to make better charts. And a recent, so this was, you know, a year ago, they had to, you know, handcraft that chart themselves. This is a recent chart, a recent initiative website created in the hub that has similar charts that, you know, basically meet the same purposes, all built with Cedar. So this is what we're working on, and we've just recently, in fact, last week, we've been working on, you know, when you create a hub page, it's a WYSIWYG experience. You're dragging and dropping cards onto a page. You drag a map card or a text card, and now we've had a chart card for a while. The only option before was that you see here on the right side to stick the Cedar JSON, that definition, into it. We now are building this sort of simplified chart builder experience into the hub that's going to create, you know, just go through those properties of the definition and add them on there. And we've just launched it last week. It currently only supports bar charts, but pretty much every couple of weeks we'll be adding a new chart type there. And what's important to you as developers is you can use what's on the left side to get a chart started. So you can go and use this tool to select a data set and then, you know, select the features that you want. And then on the right side, you can click over into JSON mode and you can get the underlying JSON. And you can then go and configure it from there if you need to make more advanced changes to this chart at that moment, or if you if you just need to take that JSON and export it out and put it in your own web application using Cedar, you can do that. One last note is that the hub is written using the Ember framework, and so we've created an Ember add-on that helps you use Cedar in any Ember application. It just it gives you a declarative tag that you can drop in, and you just pass the properties there, which makes it a little bit easier. So Cedar's road ahead. You might think that, you know, clearing out V1, getting you know, those beta gaps covered is what we would focus on. But first thing is first, we do need to work on the docs. You're pretty much looking at it right here, like this, this slide deck. But I think we're going to start prioritizing. You know, we've started to cover the needs of what we have of what our users need in Hub. We've gotten those requirements pretty well taken care of. And I think we're going to be focusing more on working with other teams, bringing in some of the smarts from Pro, making those smart defaults smarter, and really slapping your wrist when you try to create a pie chart. Expanding the Cedar API. So I talked about where you have the capability to do overrides. We want to try and make it so that you don't have to do overrides. This is going to help future-proof the JSON that you make, help future-proof it so that when we provide the ability to switch to a different underlying chart engine, your old charts aren't broken. The import here is something that I'm going to demo right now. So Flora mentioned that when you create a chart from Pro, you're able to export it or publish the service, and underneath the chart, any charts that you've attached with that layer will be exposed. So let me just pop this up. So here is a layer that she published, and this is the data for the item. So the item in ArcGIS Online. And you might be familiar with the layer definition, sort of drawing info. This talks about the renderer, but there's a new node here called charts. So she showed you in Pro creating different individual charts, and those will be serialized. The properties for those will be serialized as JSON here along with the layer. And this JSON is pretty similar to Cedar's. So type, you've got series, It's richer, it has more information. And so what we're working on is a way to import this JSON and convert it to a Cedar definition that you can use to draw a Cedar chart. And that is what this demo does here. I'll just reload this, the risk of... So this is a map that's pointing to that same layer, and drawing it on the map as you would normally expect, and then fetching the layer data and pulling that chart out and converting it using an import function that I wrote to be able to show you a chart here.
I am so excited about this, you guys.
and if you're, that's the slides. So I mean, what the code looks like, it's kind of what you might expect from this was just pulled from the feature layer sample code, grabbing a feature layer, adding it to a map, and then when the view loads, fetching the item. This should not, I think there are ways to do this. To be honest, I don't use ArcGIS API 4 very much, but I'm pretty sure I didn't see a way to instantly get the layer. You can add a layer by ID, but I didn't see how to get the metadata from it. So I had to just make an extra request here to go fetch the data. I'm not sure if that's necessary, but and basically once you get that data back, you send it to this import function, which takes the feature layer URL and the JSON for the chart that I showed you there in the layer response, and it pumps out a Cedar definition that you can then just pass on to Cedar. So what's been really cool about this conference-driven development of a demo has been, we sit around, Alexander works with Flora on their team, and he wrote that JSON specification for the chart. He came up with that. And we have all these sort of intellectual discussions around a table like, yeah, that looks good, that looks like right. Well, now that I'm actually trying to import it, I can see where the friction is. So I think this is going to really help drive those conversations and make this collaboration more real. So I'm hoping that in the next few months we'll have some good news in terms of charting across the ArcGIS platform. So that is all I have, and we're kind of running out of time. Sorry, I wasn't really paying attention too much, but I've just put up here just the slides. Those slides are rich with links to every single one of those sort of little code snippets I showed. There's a code pen for that. Again, these slides are pretty much the documentation for Cedar V1 right now. And so anyway, if you look for my GitHub at Tom Wason, I have the longest repo name in history, so there's no way you can write this down right now. But if you just look for Tom Wason in charts, you'll probably come across this. And if not, if you're having trouble, just get a hold of me. All right. Thank you.